Are there more students to come, or shall we start? Anyone? Shall we start? Are there more students to come?
You can start, sir.
Okay. Okay. See, so here you must have studied about magnetism, right?
Sir.
Okay. 1 minute. Okay. So you must have studied about the magnetic field, and in that you have derived that the like magnetic field due to the current carrying circular conductor at some axial distance, right? And you have seen the special cases where it gets to be zero. Agree? Isn't it? This is what you have done. Tell me yes or no. Till here we are done or not? Sanjay, Hariharan, Srini, any answer, please? Do you have any doubts still there? If you don't have any doubt, we can start with the solving questions. We have our first question here on the screen that says a plane of a circular coil is horizontal. It has 10 rounds, each of radius 8 centimeter. Now a current of 2 ampere flows through it. The current appears to be flowing clockwise from a point above the coil. You have to find the magnitude and direction of the magnetic field at the center of the coil due to the current. Okay, this is what we have to do. So first of all, in solving any question, you need to write the given datas. Okay, what we need to find? We need to find the magnetic field, right? What else do we have? We have n, the number of turns, that is 10. We have radius, that is 8 centimeter. We should convert it into SI unit, 0.08 meters. Okay, then we have current, I is equals to 2 ampere. Okay, the current flows appears to be clockwise. So let us say that this is the circular current carrying conductor. Okay, and this is the top face, and we are seeing from here. We are watching from here. What we'll see, if the current flows clockwise, if the current flows clockwise, Okay, that unmuting option was disabled. I'm sorry for that. Let me check. Yeah, now it's fine. Now can you speak?
Yes, sir.
Everyone? Yeah, now it's fine. That was my mistake, I guess. No problem. See it. So if the current flowing is clockwise, that means you have to go this way, right? So if the current is this way, this is the top face. This is the top face, and you are watching it from a point above it. So where do you think the magnetic field will go? Like if I draw the lines, like this, shall I give the arrow downwards or upwards? Tell me. Shall I give the arrow downwards or upwards? Curve your fingers, put your thumb perpendicular to it, and tell me the direction. Use your right hand.
Upwards.
I don't think so. Curve your fingers, and your thumb should be perpendicular. I think it should be downwards if you're watching anything from the top. Check it again. Should it be downwards? Everybody, check this again. Should it be downwards? If you curve your fingers and then the thumb is pointing downwards, it should be here like this. Agree or not?
Yes, sir.
So what is the formula for magnetic field? In a circular coil at the center, that is mu naught Ni upon 2R. Agree with this? Yes or no?
Yes, sir.
Right? Put the values and let me know the answer. Try to solve it correctly. No calculation error. For solving any question, you should have some strategy. And that strategy follows like this. First, you have to write what do you require, what are the data given, and what formulas you know to get that answer. Okay, then if you work upon this manner, you won't get confused that what you have to do in the question. Okay, you'll always have a strategic plan to solve that question.
Sir, is it 15.7 into 10 to the power minus 5?
15.7 into 10 to the power minus. How much? Tejas? 10 to the power minus?
5, sir.
5. Okay, Tesla. That is the correct answer. But for scientific notation, you should denote it like A dot B into 10 to the power minus 4 Tesla. Okay, the scientific notation you must have studied in units and dimensions. That should be A dot B into 10 raised to the power C. where A dot B, this value should be within 5 and 0.5. Okay. So this is, both are correct, but this is the scientific notation to write any answer. Got it? Shall we move on to the next question? If you have understood it, everyone?
Yes, sir. Yes, sir.
Good. Okay. So this is our next question. It says that in a Bohr model of hydrogen atom, an electron revolves around the nucleus in a circular orbit of radius 5.11 into 10 to the power minus 11 meter at a frequency that is given. So what is the magnetic field setup at the center of the orbit? Magnetic field setup at the center of the orbit. Now see, I'll be giving you some hint. See here. First of all, tell me what we require. What is the requirement of the question? What we need to solve for? Tell me.
Magnetic field.
Magnetic field. So B, that we don't know at the center. So we have a condition like nucleus is there and one electron is revolving around the nucleus in its orbit. Agree? This is only one electron. Why it is one electron only? How can we get that? Sir, how did you say this is one electron only? There are some orbits which can contain 8 electrons, 16 electrons like that. So how you take one electron only? Tell me.
Hydrogen atom, sir.
That is hydrogen atom. So hydrogen atom contains only one electron, and that is only in one of the orbit, right? So we have number of electrons, that is 1. Okay. Then what we are given it? We are given it the radius of that particular orbit, that is 5.11 into 10 to the power minus 11 meters. We are given with the frequency. We'll see how to use this. Then we are given, are we given with the current value? No, we don't know. Current, we don't know, right? So what is the magnetic field at the center? As we said in the last question, it is mu naught Ni upon 2r. Now see here, N is 1 because it is just one number of circular rotations, right? I. How to calculate I? What is I? I is charge upon time. Agree? I is charge upon time, right? What is
Yes, sir.
charge? Can I
Yes,
write
sir.
charge as number of electrons into time? Charge, like charge on one electron upon time. Do you agree with this?
Sir.
Yes.
Now see here. You know what is frequency? Frequency is 1 upon time period, na? Frequency is 1 upon time period, na? Agree?
Yes, sir.
Yes or no? Frequency is 1 upon time period. So can we write Ne into nu? Yes or no?
Sir.
Yes or no? Right.
Yes, sir.
So current is nothing but Ne into nu. What is N in my case? It is just one electron. Charge on electron, we know. Frequency we are given with. Find the current from here, substitute it here, get the value of magnetic field. Do it fast.
Sir, I'm getting approximately 1.03 into 10 to the power 7.
1.03 into 10 to the power. That
7,
is
sir.
I you are telling or magnetic field?
Magnetic field, sir.
1.03 into 10 to the power?
7.
No, this is wrong. Check it again.
Sir,
Go on, Sai.
is the value of current 10.9 and 10 to the power of minus 4?
Current value, I cannot say. I'll have to calculate that.
The n is equal to 1 and e is equal to 1.6 10 to the power of minus 19 and v 6.8 10 to the power of 15, no, sir.
Yeah, that is correct. You just put this value of current here and get me the value of magnetic field. This is what I have in the notes.
Okay, sir.
Otherwise, I'll have to calculate that. But that is not required. You just put it there. That's why I'm asking. Try to solve this. This is easy. Put the values correctly, you'll get this.
Sir,
Yeah.
it is 8.53 T, sir.
How much? How much?
8.53.
8.53.
Yes, sir.
No. Such an easy question. Why are you making such mistakes? Shall I do it? Shall I do it?
Sir, is it 4.26?
No. Are you guessing randomly?
No, sir. No.
See it. Let me do it. So mu naught is what? 4 pi into 10 to the power minus 7. And total number of rotations, circular coils, that is 1 only. Current, we can write it from here. 1 into 1.6 into 10 to the power minus 19, and frequency is 6.8 into 10 raised to the power 15. And by 2, and radius is 5.11 into 10 raised to the power minus 11. So first of all, I'll take the numerical values at one side and the 10 to the power orders that is there on the other side. So I'll have 4 pi into 1.6 into 6.8 upon 2 into 5.11 at one side. Now see here, 10 to the power minus 7 minus 19 plus 15, and this minus 11 goes up, it will be plus 11. Now you solve it. How much you're getting for this numerical value? For this numerical value, how much you're getting? You'll get 10 to the power 26. So 26 minus 19, or I guess 10 to the power 0 you'll get from here. Minus 26 and plus 26, 10 to the power 0 you'll get from here. So no 10 to the power will be there. Anything to the power 0 is 1. Tell me what's the numerical value there. What is this numerical value? You're taking so much time. So 4 into 3.14 into 1.6 into 6.8 divided by 2 into 5.11. So if I take this as 2 So 6.2428 into 6.8 into 1.6 by 5.11. 511, 680, 1511, 9, 7, 1.03, nearly 1.3, 1.6 into 1.3, 48, 16, 8, 10, 2, 2.08, 2.08 into 6.28. Tell me, what is 2.808 into 6.28?
Sir, I'm getting 13.64.
13.6. Exact answer that I have is 13.4, but this is considered 13.6 is considered. Everyone getting this answer? Agree with my solution?
Sir.
Everyone, write this down. Shall we move on to the next question? Okay. This is a good question. Let me keep it before this. Try to solve this. What is happening here? From point infinity minus this infinity, p is from infinity. Okay. Like current 5 ampere is coming towards the circle, and at point 8 is getting divided into two parts of the circle like this. Okay. And yes, this currents I1 and I2 are based on the resistances provided by these two conducting lengths. Okay, there is resistance in the flowing conductor, there are resistances. So you'll have to find the proportionality of I1 and I2 from the resistances. Then they converge at point C and then again form 5 ampere and they go to the infinity point of Q. You have to find the magnetic field at O. Try to solve this. Done. Tejas, Hariharan, Divya, Sai,
Doing, sir.
Sanjay. Shall I start doing, or I shall wait for your answer?
Sir, is it 6.28 into 10 to the power minus 5?
6.1 minute. I just check it. No, that is not the answer. I remember this answer.
Sir, or is it 3.14? Sir?
No. Answer is different. I don't even I can see that. I remember the answer. That is different. Yeah, that is not there. Shall I start? Little bit different concept is required. See here. Basically, what we don't know is that the currents in the two conducting wires, because magnetic field at the center will be due to this wire. Let me change the color. Due to this wire, due to this wire, due to this wire, and due to this wire. Agree or not?
Yes, sir.
Everyone? Now see here that current is inversely proportional to resistance, and resistance is what? Rho L by A. So if I say that the cross-sectional area of the curve ABC and ADC are same, so isn't the length ABC is equals to length of ADC because they are semicircular? Agree? Right? Now, length ABC is equals to length ADC. Now see here. So resistance RABC will be equals to RADC. Both have the same resistance. And if they have the same resistance, that concludes that the current of ABC will be equals to the current of ADC. Yes or no? Tell me. Tell me. Are you fine with this? Or
Sir.
is there any doubt? Right? So current on both the sides are same. Now tell me, what will be the direction of magnetic field due to the curve ABC at point O? Direction, just tell me the direction.
Clockwise, anti-clockwise.
No, direction of magnetic field. Magnetic field at the center O due to the curve ABC. Direction of magnetic field. Inwards or outwards?
Out of the field.
Sir, it's inwards. Sir, inwards, sir.
No, if you take the right hand, curve your fingers, your thumb is pointing towards you. That is out of the page. Out of the page. ABC, not ADC. Tejas, see here carefully. What is the
Yes, sir, yes,
magnetic
yes.
field direction due to the curve ADC at the point of direction? Just direction ADC
Into the plane, sir.
into the plane. Into the plane. So what is the formula? Formula is just, okay, one more thing. Before the formula, I need to tell you something. Now see here, when we take a whole circle at the center, current carrying conductor I, radius R. So B at center O, we write as mu naught I by 2R. Yes or no? Yes or no? So if we take a semicircle of it, and current carrying conductor, it is semicircular radius R. Okay. What will the magnetic field be in this case? If you apply the unitary method, if I say the unitary method is valid here.
Sir, no, it's not applicable.
No, it's applicable. If for the
Sir,
whole circle it is good, yeah.
Sir, because the radius is not changing, right? Radius is still the same, it's still R. How will the
Exactly.
magnetic field change?
It will change. It will change. See how you got the magnetic field for the center. You integrated it from. You integrated it. Yes or no? For 2 pi, if you remember, you must have derived this at some axial distance. You must have taken some dl length from here to here. You calculated the direction and then you integrated it, right? You did the same thing. Tejas?
Yes, sir.
And for this special case was the center, na, where x was equals to 0.
Yes, sir.
So what limit did you put here? You put 2 pi r, na? Limit for this particular DL length, you put 2 pi r. If you
Yes,
remember,
yes, sir. Yes, sir. We put
in order to get for the semicircle, you just have to put the limit pi r. You just have to reduce that limit to pi r.
Yes, sir.
Understood?
Understood.
This
Understood.
value, so that is mu naught I upon 4r you'll get. In the same way, if I take this as a quarter of a circle, radius r, perpendicular, current I, yeah. So magnetic field at this point will be what? Mu naught I upon half of the semicircle, that is 8r.
Yes, 8r.
So I should say that for 2 pi angle, my magnetic field is mu naught I upon 2r. So for 1 unit degree angle like this, if this is the case, for 1 degree angle, magnetic field will be what? Mu naught I upon 2r into 1 by 2 pi. Yes or no? Agree?
Yes.
So for theta angle, any theta angle, random theta angle, it will be mu naught I upon 2r into theta upon 2 pi. This is what you have to remember. Understood? Put theta 180 degree, just pi, you'll get the semicircular formula. Put theta 90 degree, pi by 4, you'll get the quarter circle formula. Put theta is equals to 2 pi, you'll get the whole circle formula. Agree or not? This you should remember. Got it?
Yes, sir.
So B due to ABC is mu naught I upon 4r. B due to ADC is mu naught I upon 4r. In both the cases, the radius is same, the current is same. We just proved it here. And they are equal and opposite. BABC is equals to minus of BADC, equal and opposite. Right? In that case, the whole circular part, the magnetic field due to the whole circular part will be cancelling each other. So magnetic field at the center O will be just due to magnetic field due to the length AP plus magnetic field due to the length CQ. Do you agree with me here or not? Tell me, yes or no? Yes or no? Everyone, Hariharan,
Yes, sir.
Adav, Tejas, Divya, Sai, all of you.
Yes, sir.
Yes,
Sir.
sir.
Right? Now tell me, what is the magnetic field due to this length AP at this particular point? So you have to apply this formula. Let us say that we have to calculate the magnetic field at this particular point O, and we have the perpendicular distance A. The left hand side and right hand side angle are phi 1 and phi 2. So what used to be the formula? Tejas, you remember? You remember this? Divya? Anyone? Mu naught I upon 4 pi r. Let us say that this is not A, this is r, into sine of phi 1 plus sine of phi 2. Remember this? Yes or no? Do you know this formula? Yes or no?
Yes, yes, sir. Yes.
Right? So in this case, the left hand side, the angle is 0. And right hand side, since this is coming from infinity, so angle will be nearly 90 degree, because this line has to join the infinity, and that it can never could. So that means this angle will be 90 degree. Phi 1 is 0, phi 2 is 90 degree. So if you put that value, B will be mu naught I upon 4 pi r, and this is the r, that is equals to the radius here, sine of 0 plus sine of 90 degree. So you get mu naught I upon 4 pi r only, because it is 0, this is 1. And can you tell me what is the direction current is this side, what will be the direction of magnetic field at this point O? Due to this current 5 ampere this side, is it perpendicular inside or outside? Tell me.
Outwards.
Outwards. Yeah, that's correct. How you have to do? You take your fingers along the direction of current, face your palm at the point at which you have to calculate the magnetic field. Put your thumbs perpendicular and that will show you the direction. So that shows the outward direction. And now tell me, what will be the magnetic field due to this length CQ in this direction? Inside or outside?
Outside.
Outside. Again outside. If you take it this way, palm facing upwards, point O, and thumb pointing again outside the screen. At the same radius R, with the same current, so magnetic field due to this was AP, and for CQ, I'll write the same thing. Mu naught I upon 4 pi R sine of 0 plus sine of 90. So that means magnetic field due to AP is equals to magnetic field due to CQ. Agree? Yes or no?
Yes, sir.
Right? So magnetic field at the center O is due to magnetic field AP plus magnetic field CQ. Find this value. Find this value. Any one of them you find and multiply it by 2. Find this value quickly. Solve more questions. Try to be in a habit of solving questions, numericals easily, and in a very shorter interval of time.
So is it 4 into 10 to the power minus 5?
No. A bit close. Check your calculations again.
So 2 into 10 to the power minus 5.
Yeah, 2 into 10 to the power minus 5. So what is this? Mu naught upon 4 pi, value is 10 to the power minus 7. Current is already given, that is 5 ampere. And the radius is how much? Radius is 10 centimeter, that is 0.1. Right? Mu naught by 4 pi, I upon, okay. Diameter was 10 centimeter, radius is 5 centimeters, so 0.05. So this becomes 10 to the power minus 5. So this was for one of them. If both of them are equal, so 2 into 10 to the power minus 5. Agree with this, yes or no?
Yes, sir.
So I have a question for you as homework. This is interesting. So this is a circle O. This is a circle center O. One current is coming from here along the axis of the center. And this is carrying current, let us say I. And there is one more wire that is taking away this current from here. Again along the axis of the center. So what would have happened here at this point A and point B, C and D? Okay. After coming to this particular point, this current I must have got distributed among here and here, and they would have converged here and here. Agree? Yes or no? Say yes or no?
Sir.
So you have to calculate the magnetic field at this point too. This is a good question. Okay. HOTS kind of question it is. You may solve this as homework. And one more thing, you can take this as a screenshot of this particular question for homework. Taken?
Sir.
Okay then. So do you have any doubt in the question that we did today?
No, sir.
Everyone? I want the answers from everyone. Avat, Tejas, Divya, Sai. Any
No
more
doubt,
students are
sir.
there? Yeah,
No.
more Sanjay, Akshita, Ashwin, Ananya, Prakash.
No doubt, sir.
Good, good, good. So shall we keep it for today? Written? Tejas? Divya?
Yes, sir. Written.
Yes, sir.
Okay, okay. Okay, then that's all for today. I hope you liked the session. Bye. Thank you.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.